Hello, my name is Professor Adrivan, and this is episode 11 in the Quadratic series, and we're going to start talking about how to solve quadratics. And the first way that we're going to talk about solving quadratics is using something called the square root method. We're going to be doing 3 examples in this video. The 3 examples are on your screen now, so if whatever you're working on, your homework, whatever it is, if it looks like these problems, this is the video for you. If you're looking at these problems and you think that you're confident that you can solve these, I recommend going on to the next episode in the quadratic series. But for everybody else, we're going to go ahead and jump into it. So before we start solving quadratics, let's take a step back and remember what the word solve means in terms of mathematics. Solve just means, what does x equal? So if we think about a linear equation such as 3x plus 7, if we wanted to solve this for x, that means we need to isolate the x. We need to get everything else that isn't the x on one side of the equals so we can have x equals some number. So the way we would do that in this linear case would be subtract the 7 from both sides and then divide both sides by 3 and get x is equal to negative 7/3. Another word that you might see instead of solve would be find the zeros of the equation, and the reason why it's called find the zeros is because the equation is set equal to 0 and we're looking for the values of x that output a 0. It could say instead find the roots of the equation. And this is going to make sense in a little bit when we do the examples because we're going to be using a square root to find our answer. It could also say find the x-intercepts because that's really graphically, if we think about it, what we're solving for. When is it equal to 0? When is the output or the y equal to 0? Well, that would be an x-intercept. So the words solve, zeros, roots, x-intercepts, they all are asking the same question, and they're all going to be procedurally done the same way. All right, so let's look at it with one of our examples. If we approach this the same way that we just did that linear problem, where we isolate the x on one side of the equation and get everything else to the other side, we would add 48 first and have 3x squared equals 48, and then divide both sides by the 3. Everything is exactly the same way as it is with a linear equation thus far. So 48 divided by 3 is 16, and then this is the one new step that we have when we're dealing with a quadratic rather than a linear equation, and that's to get rid of this squared, we need to take a square root. A square root will undo the square, leaving us with just a x. Now what is the square root of 16? Well, it is a perfect square, so it's 4. However, it's not only 4. We know that 4 times 4 is in fact 16, but negative 4 times negative 4 is also 16. So we get two answers. We get not only 4, but we also get negative 4. Another way I could write this answer is that x is equal to plus or minus 4. Alright, these both mean the same thing. Alright, let's do another one. Negative 5x squared plus 60. So we're going to do the same strategy. I'm going to take the number that is not with the x, 60, and I'm going to move it across the equal sign. So in this case, it's positive. To move it across the equal sign, I need to subtract it. Now I need to get rid of the number in front of the x, -5, and we do that by dividing because division is going to undo the multiplication. And -60 divided by -5 will give us +12. Now we take our square root to get rid of the squared and be left with an x. And what is the square root of 12? Well, 12 is not a perfect square, so some of you might be quick to grab your calculator and get a decimal answer. And before you do that, I would make sure with your teacher, if that's what they're looking for, if they're going to accept a decimal answer. I know myself and most teachers will want you to simplify this answer. So the way we're going to simplify it is look at what two things multiply to make 12, and I want one of them to be a perfect square. So remember, our perfect squares are 4, 9, 16, 25, 36, 49, and so on, right? 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. So we can come up with 12 by using one of these numbers times something. So we can rewrite 12 as 4 times 3. And I can rewrite this root as the square root of 4 times the square root of 3. And I know that the square root of 4 is equal to 2. So I can rewrite this as 2 square root of 3. And not only 2, but positive or negative 2 square root of 3. I do have a video planned that is talking about how to simplify radicals, so be on the lookout for that. We have our third example. Following the same process, we're going to move the number that is not with the x across the equal. In this case, we do that by adding 21. So we have 6x squared is equal to 21. And then we divide by the number in front of x. Dividing by 6 gives us x squared is equal to, and this does not divide evenly. We don't get a whole number. So again, before we grab our calculator, let's see if we can simplify. Do these share a common factor? They do in fact share a common factor of 3. So we could rewrite this as 7 times 3 over 2 times 3, and then cancel the 3's out, and have x squared is equal to 7 over 2. Now to get rid of the squared, we take the square root. So I know I have an x equals, and how do I deal with this when I have a square root of a fraction? Well, this means that we have the square root of the top and the square root of the bottom. So I have the square root of 7 divided by the square root of 2. And we cannot have a final answer with a square root in the denominator. So I need to rationalize this. I'm going to rationalize it by multiplying both the top and the bottom by my denominator. Because when I do this, the square root is going to cancel. The square root of 2 times the square root of 2 is just 2. So the square root of 7 times the square root of 2, I can multiply the numbers under the square root, have the square root of 14. And of course my final answer is always plus or minus. And I do have one final example, a bonus example, if you will. It'll take just a second. Following the same process, minus 18 from both sides. Divide both sides by 2. And then if I take the square root of both sides, you might be quick to assume, because I see a 9 here, that it's going to be this plus or minus 3. However, it is a negative 9. What two numbers that are the exact same numbers multiply to make negative 9? Well, 3 and 3 make positive 9. Negative 3 and negative 3 make positive 9. There is no way to multiply the same number by itself and get negative 9. I would need 3 times negative 3, but these aren't the same numbers. Okay, so this does not work. In this case, and only this case where I have the square root of a negative number, I can say that my answer is no real solutions. Instead, I'm going to get something called a complex number. And I also have a video planned talking to some extent about complex solutions when dealing with quadratics. So again, be on the lookout for that. If this video helped you out, go ahead and give it a like and consider subscribing for more math lessons. If you have any specific questions, please comment them down below. I'm very active in the comments and answering any questions that you might have. And if you have any suggestions or videos of certain specific math topics that you would like to see, go ahead and comment those as well, and I will add them to my list of planned lessons. All right, thanks, and we'll see you in the next one.